hear as kids. We hear it in cartoons. We hear it in movies. People talk about this. There is a device called a centrifuge. Well, this is centrifugal force, and this is something that people have heard of. The problem with centrifugal force is it does not exist. It is a phantom. It is totally incorrect and absolutely not there. So here's what we're getting at. First, we got to talk about our own experiences, right? And the simplest thing I can point to is to say, look, and you would agree with this, when we're twirling something around in a circle, what do you feel in your hand? You feel a force pulling out. That's what you notice, right? Okay. And I would agree. I would notice the same thing. That's not a problem. There's something else. If you drive around a turn in the roadway, and let's say you drive around a little too fast through the turn, well, doesn't it feel like your body inside is being thrown this way? Don't you feel like you're getting pulled to the outside of the turn? So the car might be here at some point, and you're going pretty fast through the turn, maybe a little faster than you should be. Hopefully you're still safe, but you feel like you're kind of thrown out and pushed against that door of the car. That's what you feel. When you're on a swing set, let's see if you can imagine this. Right? And you're swinging. So imagine the seat of the swing here. And you're coming down near the bottom of that arc. What is it you feel? You feel pulled down even more than your own normal weight. It sure seems, based on our experiences, that there is this outward pulling force, right? In all these situations. The problem is it isn't there. It simply does not exist. Here's the thing. Here's what's really going on. You ready for this? Talk about myth busting. If you're going around a turn, you're going to start going straight, and the road curves, and you're just going to make this right-hand turn. You start going up this direction. As soon as the road starts to turn, you have to think about this. Your body inside the car was already on this path going straight. Newton's first law of motion, the law of inertia, essentially says, you know what, look, if your body was not disturbed by any forces, it would continue to go straight. That's what it would happen. But the car wants to go away from you. The car actually wants to go this way, and it's forced to. That car has a force exerted on it, friction with the road, and it is toward the center of the circle. So that force absolutely exists. But that force aimed at the center really is a force acting on the car. And as the car's door moves to the right, it sort of bumps into you. And you think you're being thrown out against the door of the car, but you're really not. Your body's just trying to keep going straight. That's all that's happening. And yet you sense like you're being thrown outward only because really what's happening, the door of the car is being thrown into you by this force. It's being pulled into you by that force until the turn stops, and over here now you're going straight, and that force has gone away, and you no longer feel the car door bumping into you. That's where this comes from. There is no outward force. This blue arrow is a myth and does not exist at all. There is no such thing as centrifugal force. So please keep that in mind. No. There is only this force toward the center. Here's another way of looking at this, right? Remember this. But I feel it. You feel it too, Mr. Woods. this force pulling out on your hand? Well, yes, I do. And the trick is this. The trick here is to recognize that your hand is not the thing moving in a circle. The thing moving in a circle is this out here. And we're concerned with the forces acting on that thing. And the only force that we're concerned with that is not canceled out really is that force toward the center of the circle here. It would be equal to the force pulling out on your hand, but your hand is not moving in a circular pathway. And so, yes, this force exists, but only as a reaction. Remember Newton's third law, action-reaction. So you pull the ball in, the ball pulls your hand out. That does not mean this is centrifugal force. It is not. It is simply a reaction force. That's all it is. Your hand is not going in a circle. This is. The only force of consequence here that is not balanced is the force toward the center of the circle. That guy right there. That's what matters. There is no such thing as centrifugal force. It is something that we think we feel it. It is imagined, but it is only apparently there, like your apparent weight in an elevator. When the elevator accelerates up, you feel heavier, but you didn't suddenly gain weight. In orbit, in the International Space Station, the astronauts feel weightless, but they aren't. They still have weight. It's just a matter of their feeling, their sensation. So the same thing is fooling us here. All right, enough of that. So here's what we have looked at, right? We have seen that with circular motion, we had to look at Newton's laws and refresh our memory a little bit about acceleration and force. Object moving in a circle could be constant speed, and that's what we're going to say. The speed will be constant, but the direction clearly is changing with time. We saw that we could carefully look at what was going on there. Let me get that out of there for you. And we saw the direction of the change in velocity. It's never headed toward the circle or toward the center, but the change in velocity is pointed at the center. And we also see that because of that, acceleration is always pointed at the center, and net force is always pointed at the center. That acceleration has a name, and that is called centripetal acceleration. And here's the symbol typically used for it. It's equivalent to the speed squared divided by radius of the circle. And we also have a name for the force. That net force, we can call it centripetal force. We're fine calling it net force if you want. In this case, or problems like it, it's easy to see that tension is what creates that force. Some cases, it's not so easy to see what causes it, but here friction with the road is what's causing it. And we can put the two equations together and we get this relationship, and that's going to be a good one to work with. And then finally, we figured out that this whole idea of a centrifugal force is a myth. We think it's there, we think we feel it, but no, not there at all. Hopefully this worked out for you. Let me know if you have questions. Thank you for watching. I'll catch you next time.